Thank you, everyone. As we know, and I probably don't need to say it, we are truly at a unique moment in time. We have three deeply impactful pillars that are converging at this moment in time. The build-out of essential AI infrastructure has started. The deployment and use of AI tools has started. And for this audience, we all know that the definition of the next generation of wireless networks, 6G, has started. While this is a unique moment in time, and it's exciting, let's be honest, it's also a little bit daunting. Most of us imagine the vision, but where do we start? How do we connect that vision to these first milestones? That's what we're going to talk about today. We are in a new era. It's only 3 short years since that ChatGPT moment. And we've already started this AI revolution. And just like other revolutions, in industrial revolutions, the past is no longer indicative of the future. We must, and we have to think differently. Some of us are already starting on that journey. I'm going to talk about some of that today. But for the others that really want to think about how and what do I do next, let's lay out those milestones of how we can move into this new era and take advantage of this new era. Because in telecoms, we need to. This isn't a might do, this is a must do. So, firstly, most of us are connecting to generative AI on our mobile phones. We're already doing that. We're already seeing the benefits of having these applications available on our mobile phones. What we're not seeing is that the network traffic is already increasing as a result of that. Some are predicting that by 2030, we will have 4-fold increase in network traffic. But again, that's a prediction. We may be completely underestimating it. The CTIA here in the US talked about already in a report this year that we will be, by the end of 2027, 10 exabytes per month short on spectrum, which over a 10-year period will result in a $1.4 trillion loss of economic growth. So while we need to add more spectrum, make more spectrum available, we also need to be much more spectrally efficient. What I'm going to show you now is just one small example of some of the new generative AI applications that are starting. This is a company called Descartes AI. You engage with this application on your mobile phone, and what we thought we would do in NVIDIA is we would actually monitor the traffic, the throughput, the signal throughput that comes as a result of using this application. So what we looked at is both the uplink, which is the white line, and the downlink. So the upload traffic and the download traffic. It's a really interesting app. What you can do is you can upload an image, and then you can talk through that image, but you can give prompts on your mobile phone. It says, make the person wave an American flag. Then what you can do is you can also adjust or amend the video with your prompts as well. What you're going to see is the amend of the video. But watch the traffic, what happens. And then, interestingly, what you can also do is you can live stream video from your mobile phone, and you can give it a prompt to adjust the video in real time. How cool is that? We all know that this type of application is going to get utilized heavily. But what we also don't know is in the infrastructure that sits behind this. Not only are you adjusting how the traffic is dealt with over the radio access network, and we did this on a live 5G network. We recorded this video at the NVIDIA campus. But what we also have to do is adjust the compute architecture. And that's what Descartes has been able to do. So let's just play this video and show you how we go through that. And keep your eye on the uplink and downlink. So here, I'm uploading a photo. And you'll see who the photo is of. And here I am now waving an American flag. You can see, as we're downloading that video, you can see the spike in traffic. What's interesting about this, now I'm actually adjusting the video. Wear a green jacket. Again, look at the traffic, bursty. That's not normal, bursty traffic. Now we have a live stream video, and we're saying put American flag in the background, standing in a city. Look at that uplink and downlink. Just imagine millions of people on their phones doing this. This is leveraging a small language model, a distillation of a large language video model. Compute architecture is important. The new era of tokenization. This is how the telcos, the equipment providers, put more value into the network than historically has been possible. We heard yesterday about AI factories. AI factories are essential. The outputs of AI factories, while we're still putting bits over the air and pushing more bits through the spectrum, the output is monetizable. The KPIs are new. Time to first token, tokens per second. These are now tokens per dollar, tokens per watt. These are new KPIs, but they're monetizable KPIs. Now, how do we deliver these AI factories? How do these AI factories deliver these KPIs, these new tokens? Well, we all know that there's been a large infrastructure build out, and that's starting. I said that earlier as part of this overall unique moment we're in. But what we haven't perhaps realized, because it's been a much maligned word in the past, is the importance of the edge. The importance of AI factories that can sit at remote distributed locations. There's a tremendous interest now from all of the providers of the AI factories on the edge of the network. This is really a truly unique moment in time that we can take advantage of. So spectrum, fiber, networking, storage, land and shell, power, words that you know, except a few new ones, spectrum, fiber, networking in AI factories. Those are new words. Those are important words. Cloud providers, neo-clouds, on-prem data centers, edge providers, everybody's interested in this edge to provide consumers, enterprises, and nations new capabilities. We have given rise to the AI grid. The AI grid is a connection of AI factories, large and small, tokenized, monetized, important, not just because of the location, but because the compute architecture can be managed. The storage can be managed. You don't have to send data all the way back to a cloud, expensive video data. You can deal with it at the edge in video language models, video search and summarization. These are all new words to the telco industry, but all important words and words that will become a matter of course. The AI grid becomes essential. Much interest in that grid. And we are pleased to announce that we are working with Akamai. Akamai, a content distribution network provider, is interested in that edge and is deploying NVIDIA Blackwell-based GPUs and connecting with DPUs all the way out to the edge on their AI inference cloud. The AI inference cloud that will be distributed globally. This is just one of our partners that's interested in that edge of the network. But this is a golden moment for telcos. You can tell by what I've already said. Don't think about the past, the monetization only of ARPU, but think about the monetization of tokens and what that can provide to telcos. Absolutely a critical new era of monetization. Seize this moment. There's significant advantages that telcos have. We talked about the AI grid, the locations, the POPs, the mobile switching offices, the baseband hotels, all these locations that have land and power and connectivity and can provide that monetization opportunity. And as you can see, there are new applications that are starting to be delivered that can be hosted in those new areas. So invest in AI infrastructure. That's the key message. Seize this moment. It may surprise some of you, probably not all of you, that if you look at the revenue growth of the cloud and the revenue growth of the mobile industry, what you can see is the mobile industry has tremendous volume. Of course, billions of people around the world connecting. Telcos making ARPU, providing products and services that are essential to economies and to people. Great experiences. But look at the trajectory now of the cloud revenue. Look at the trajectory of the telco revenue. The important point is that we can now in the telecom industry can capture, grab onto that trajectory of cloud because of the installed base that want these products and services that can be delivered by the telco network. A completely new era. Don't think about the past, think about the future and the milestones that you need to follow to get to that future. It's a different way of thinking. That's what's really essential. Let's take a moment to think about how rapidly AI has been proliferating. How absolutely astounded we are on the proliferation. It was probably 3 years ago. I was at Mobile World Congress in Barcelona. And I happened to mention AI in an interview I was giving. I'm so glad I did. But other people said, well, why is he talking about generative AI? Remember, November was when ChatGPT came on. February was Mobile World Congress. That thought process was very unique still. Now you go to any conference, it's hard not to mention AI. But what's not perhaps as obvious is if you're a researcher and you're working on publishing a paper, if you're in the AI world, your paper can very quickly make it to production. There is no time lag, no latency between paper to production in the AI world. Now think of a researcher in telecoms. How long does it take for that research to make it to production? Years. What we need to do is put telecoms on hypersonic growth like AI and use AI to do that. But at the same time, we also need to put the deployment of production on hypersonic growth. We can do that by changing the infrastructure of the telecom network. Of course, there's always going to be spectrum, there's always going to be wireless network, but think about making that now software defined. You can take advantage of the speed of software feature releases. You're not dependent upon silicon releases. It's AI native, meaning that there's ability to provide AI advantage for AI for RAN, and open innovation, open up to allow others to innovate in this software-defined world, accelerate that innovation. That's the hypersonic growth principles that we need to bring into the telecom world. It does need a different infrastructure. If you take the most important workload for the telecom world, the radio access network, that's the most important, the primary tenet of infrastructure, traditionally delivered on single-purpose compute, silicon-dependent, silicon tied to software. How do you innovate rapidly? Take advantage of that trajectory of rapid innovation of the cloud. You need to move to a multi-purpose infrastructure, software-defined. But you can't lose the performance of the RAN. You cannot make this a very expensive proposition. You can't increase the TCO. There are certain requirements on the radio access network that will always stay. Yes, we have monetization opportunities on top, but there will be RAN only in some locations. Software-defined, AI-native, open to innovation. These are the absolutely critical points that we need to think about. So, as we heard yesterday from Jensen, the telecom industry, network equipment providers, has really not been present in the US for some time. What we decided to do at NVIDIA is work with an ecosystem that could take advantage of these principles that I just talked about. This ecosystem rapidly is coming together. It's critical that we're able to take advantage of the software-defined, the open innovation, and the rapid deployment of some of these key research areas. So what we've been doing is working with some key researchers. Just a few of these are mentioned here. But you'll be able to see a lot of this innovation down on the floor today. If you go to the Telecom Pavilion, you'll be able to celebrate with some of these innovators and some of these companies the true advances that are being made in this space. And we're also pleased to be able to work with operators in this space on AI RAN, the combination of AI and RAN together. Absolutely, I would say, important movement that started back in Mobile World Congress of 2024, when it was first announced by 10 of the founding companies. Now well over 120 companies, part of the AI RAN Alliance. You'll be able to see their booth also, the AI RAN Alliance, down on the floor. Please go visit it. Well worth a visit to see how fast this has moved along. The AI native wireless networks are the way the future is going to be built. Just a few months ago, we announced the AI Win companies that are working together to really accelerate this innovation in the US. Key features of 6G. The AI Win initiative has been working together in companies. We put aside bureaucracy. We said, how do we make this move forward? How do we really add new features, new 6G features from demonstration into practical world? What we're starting to do already, and you'll see some of this on the floor today, these companies have provided amazing, absolutely amazing results within just the 6 months. This is one of the examples of how quickly, once you move to a software-defined stack, you can start to innovate on top of that. So a big shout out to these companies that have been working together to make that happen. Let's look at a video and see just some of these features in play.
Wireless networks are critical infrastructure, connecting more devices than there are people on Earth. Soon, intelligent cameras, cars, and robots will create hundreds of billions of new connections. NVIDIA AI RAN modernizes wireless infrastructure into intelligent 5G and 6G networks, delivering scale, spectrum efficiency, and AI where the users are. In just 6 months, NVIDIA and our partners built the first AI-native wireless stack, made in America, powered by NVIDIA AI Aerial. It's already running applications like spectrum agility. When radar interference would normally shut an entire system down, AI freezes only the affected frequencies, keeping the rest online. Another development enabled by the AI Win platform is integrated sensing and communications. Researchers are fusing camera vision and radio into a sixth sense for wireless networks, able to spot and track an object's location and path, even when camera feed is lost, all in real time. With NVIDIA AI Aerial, wireless is no longer just about connecting devices. It's about connecting intelligence.
So while that video went quickly, there were some key features in that video that they portend to the future. Integrated sensing and communications. As you start to think about the world about us, of course, it's a dynamic world. It's not static. We need dynamism in the interpolation of how we interpolate that world within a wireless channel. But at the same time, we can learn from that dynamic world. We can actually use the radio access network as a sensor. We can detect objects, like you saw somebody walking in the lab. But you can detect drones. You can detect objects just by the wireless network. You can introduce multimodality. Yes, you have RF signals coming in, but at the same time, you can use camera feeds, you can use LiDAR feeds. You can put that into a pipeline and you can use all of those feeds and aggregate them to detect the world and sense the world around you. These are key features, not just for some of the defense type applications, but of course commercially, where you can monetize the availability of a sensor network. These kind of key features that we're already seeing in the spectrum sensing that you saw as well, how to improve spectral efficiency, are essential aspects of moving forward into 6G. And we're demonstrating them already. What we need to do, as I said earlier, is move at hypersonic pace. Hypersonic pace isn't just about the commercialization of the network, but it's actually about the research that needs to happen. In early 2024, NVIDIA announced our 6G developer program. This is a program where we bring a lot of our tools and capabilities to researchers around the world. We are now at probably around 2,500 members of that 6G developer program. Researchers that were unable to do their research prior to this and demonstrate their research in real-world examples are now able to do that because of the tools and capabilities that they have access to. Now we need to move that from research to demonstration and into standards. We need to bring the speed of AI into telecom. And that's what we're able to do. If you just look at some of the facts and figures here, 200,000 downloads of Shiona. Shiona is our link layer simulator that has ray trace extensions that you can use to simulate the physical layer. 500 paper citations of Shiona. We have, as I said, over 2,000 members of our 6G developer program. So this virtuous cycle of rapid prototyping now needs to move into that rapid production. The way we can do that, of course, is in this software-defined world, is not be dependent upon silicon cycles. 350 institutions alone in the US are now using these tools. So what we would like to announce today is that we are bringing 6G research to DGX Spark. Some of you heard yesterday in Jensen's keynote that in 2016, Jensen went to OpenAI and delivered the first supercomputer, DGX. That amount of performance is now in the DGX Spark. We are enabling 6G wireless researchers to use DGX Spark. Also, we're running the AI RAN tools on top of DGX Spark. Why? Because they're software defined. Also, importantly, NVIDIA has been working on a product called Aerial for some time. Aerial has a lot of products underneath that umbrella. One important part of that is also the physical layer, the layer 1. But what we're doing today is we're announcing that we're open sourcing all of Aerial. We are enabling researchers around the world and companies around the world to have full access to all the work that we've been doing over these years and will continue to do in an open source environment. Let me also show you something. The Shiona Research Kit. Here, in a suitcase, you have DGX Spark, a full radio base station. We are able to run a neural receiver, ray trace environments, all within that DGX Spark, real time. You now have the ability to take this out in the real world, so going from hundreds of thousands of dollars of research equipment to a few $1,000s. That's now available to researchers around the world. Let me just show you quickly an RF coverage map of, you may recognize that in the middle, the conference center we're sitting in right now. This coverage map is based upon real base stations deployed. And one, as I play it, you'll see the base stations are getting deployed now. One DGX Spark can render this radio map for a typical city in a few minutes. To render the whole continent, you can do in 5 minutes on about 96 L40S. So you can take your simulation from the DGX Spark out here. Here now you can fine-tune your wireless algorithms in a real-world environment. This is physically accurate real-world environment. We also now adding into our family of products, our research platforms, all built around a software-defined principle. The Jetson Aura and the DGX Spark, the larger aerial testbed that many researchers are using. We announced the ARC Compact and ARC One, which is more of a C-RAN implementation of our infrastructure. We are now adding, as we heard yesterday, a new aerial RAN computer, ARC Pro, suitable for base stations, out at the cell site. And we are very, very pleased to announce that we are working with Nokia, one of the leaders in the wireless industry, one of the most important companies to the world of wireless, to the telecom operators, is now working to bring their software on top of ARC. This is truly a momentous moment, and I would like to celebrate that moment by bringing up Justin Hotard, the CEO of Nokia.
Thank you, Ronnie. It's great to be with you today to talk a little bit about this partnership. But I actually want to start in a little bit of a history. Let's think about the industry, because Ronnie talked a lot about why the time is now. Well, let's go back and think about where we are in the telecom industry. In fact, I'm going to go back, which for some of you in the room, you'll remember. Some of you will probably sound like a long time ago. But back when I was an engineer building 2G networks. And I know I don't look that way, but I was an engineer building 2G networks, and I wasn't 5. But nonetheless, when that happened, something transformative happened. 2G was about digitization of voice. And for those of you who remember that at that time, the way you made phone calls was you'd have a home phone, you'd have an office phone, you might even have this thing called a phone booth. I don't see them, very many of those in Washington, D.C. today. Those devices were also stitched together with bag phones, old analog phones. When digitization happened, what happened? We digitized voice. Voice was actually better than most of those other experiences. So if you started using CDMA or TDMA, for those of you that know the industry, it transformed it. People stopped. There was a phone in your hand, a phone in your pocket, and people stopped just relying on a home phone, an office phone, or a phone booth. It was transformative. The industry changed. We had a massive leap forward in productivity, a massive leap forward in connectivity. And this little company in Finland called Nokia put a lot of those devices in people's hands, and we talked about it as connecting people. So then what happened? Well, Ronnie showed you a beautiful graph of cloud computing. Before that was the internet era. And you know, as the internet boom happened in the late 90s and into 2000s, what did the telecom industry do? We built 3G networks. 3G networks were about building better voice networks. Then the iPhone moment happened, 2007. 3G first, the application and data revolution happened. All of a sudden, people realized, I want richer content. The internet was pushing, the beginning of streaming was happening. The internet was pushing richer content, more applications. What did we do? We started to tiptoe into data with 4G. And we said, gosh, we need rich, robust, rich content, differentiated services. So we came up with 5G. And then if you look at 5G, we're in 2025. And actually, when you look at 5G penetration, outside of China, where it's at about 80% true end-to-end networks, it's really low. In the US here, it's about 30%. We'll talk about that, why it's 30% in just a minute. But even if you look at Europe, for example, where we're based, it's under 10% penetrated end-to-end. And so it's not just the little 5G logo, that's the marketing that everybody puts on your phone. It's about the complete set of services. So today, we're not even capturing the demand for rich, robust data services. Now, Ronnie just showed you a picture of what's happening today with Gen AI. And just as he highlighted, if you think about the journey we're on today, 800 million ChatGPT weekly average users, according to Sam Altman yesterday, in some news that they released. The majority of that, when you look across all of these applications, Perplexity, Gemini, obviously what we're seeing with ChatGPT, Grok, all of these Gen AI platforms, the majority of use is on your mobile phone. Mobile devices are driving use. And Ronnie showed you a great example of how the data pattern is changing. And in fact, what we see from our research is 9x increases in uplink traffic. That's completely reshaping how traffic is going to be built. The second thing that we see is we're barely penetrating the mobile network today. It's only about 5% use. So if you just fast forward and you think about where we need to go and what 6G needs to deliver, we need a different moment and a different experience. And by the way, today in 5G, the most incredible thing is those operators that have invested in networks, they're reaping the rewards. There's a wonderful example, our largest customer here in the US, T-Mobile, and we're so honored to be a part of their network, but they went all in on 5G. They're at 5G in their core networks, 5G in their radio networks, the best coverage. They have the best network in the US. They have the best customer experience in the US. By the way, if you look at the results, the financial results, they have the best revenue growth, they have the best financial return. Why? Because they invested in technology. By the way, for those of us that live in technology and other parts of the IT industry, this isn't a shock. This is the story of cloud. It's clearly the story of AI. It's the story of all of these technologies. When you invest and differentiate in technologies, the results come, the experience comes. Why? Because it delivers better experience, better productivity, and tremendous value. And so we're seeing this start to play out in AI, but it's very clear that as an industry, we're not ready for it in telecommunications. And that was the case until yesterday. Now, let me explain why we announced what we announced yesterday by giving you a picture of the future. Ronnie touched on this with just a few examples. First, the future isn't mobile devices. Today, everything we talk about is basically a mobile device. Your phone is a phone. Your car is treated like a phone. Your watch is a phone. You pay a monthly subscription fee. In the past, we've been connecting people, connecting devices. In the future, it's all about connecting tokens, connecting intelligence. Why? Because what's coming is autonomous vehicles, robots, smart cameras, real-time virtual reality. And that can't just run on Wi-Fi. It needs to be out in the public domain because it's going to be really hard for an autonomous vehicle to stay connected if it has to hop through Wi-Fi networks every place it goes. It needs modern networks. It needs 6G future networks. And 6G will be about AI-driven networks. But we can't wait for 6G to get started. And that's why we started with this partnership. And in fact, at Nokia, we've been at this for a little while. We started pioneering this in our core networks. We're now cloud native, cloud first across all of our core networks. And in our RAN networks, we started to build a platform called AnyRAN. It's our software stack. It runs on AirScale. And if you're a customer today of Nokia AirScale platform, you actually have a software platform embedded in it called AnyRAN. AnyRAN is actually a cloud native stack. We just don't talk about it much. And in fact, Ronnie talked about the AI RAN Alliance. For the last year and a half or a little bit more, we've been working on running AnyRAN on a GPU and making it an AI RAN. So when you go to our booth, which you should all do, when you go to our booth down in the convention center here, and you see the demonstration, what you're going to see is intelligent cameras running connected wirelessly to a 5G stack, running AnyRAN AI, powered by a Grace Hopper 200. That Grace Hopper 200 is running our radio stack. It's managing communications, and it's providing image identification and threat detection. And once it identifies an image, it actually is using local offload on the AI stack to identify the threat. It's incredibly powerful because it shows something that we cannot do today on just our existing hardware. And it shows the power of AI native software running on accelerated computing. Where we're headed is a revolutionary network deployment for 6G with an evolutionary step. And so what we've announced with NVIDIA as a part of this partnership is that the aerial RAN computer Arc Pro will actually be hardware upgradable into the AirScale platform. That means for all of our customers around the world that deploy AirScale, they can actually hardware upgrade that platform by just adding the NVIDIA Arc Pro and upgrading to our AI RAN software version with AnyRAN. And the great thing is, once you get on this roadmap, you're not stuck, you're not wedded to hardware. The transformation for us is now we can give you better performance because our platform will be continuing to learn. Our application will continue to learn. It will continue to improve. And if you look at the testing that we're doing already, we're already seeing comparable performance on our network in 5G. So as we get to 6G, we know that we'll see disruptive levels of performance. And that's the story here. The other thing we announced is with Dell, a Power Edge solution, so that for those customers that want to go down a more standard, common off-the-shelf server alternative, we can do that as well. Because ultimately for us, it's about running software across a broad array of platforms and giving our customers choice on how they want to deploy their networks. But ultimately, this is about a fundamental shift. I'll go back to where I was. 2G was about connecting people. The reality is, for the last 3.5 decades, we've been connecting people. The future is about connecting intelligence. And that's what we're doing at Nokia. And that's why we're so thrilled to partner with NVIDIA. But we're also thrilled to partner with one of our best customers and our largest customer in the US, T-Mobile. And I thought it would be great to have Ankur Kapoor come up, who leads networks for T-Mobile. Ankur, I would love for you to come up and talk a little bit about what we're doing together.
Thank you, Justin.
Thank you, Ankur.
So exciting to be here. I was talking to Justin yesterday, and this is how I summarize the conversation. And I think Ronnie touched on it. This is the moment where wireless connectivity is being reimagined. This is the day. This is once in a lifetime opportunity. With America's best network that T-Mobile has, we are committed to the next and future generation technologies. And what you heard today, it's not about any wireless network. We are laying the foundation for 6G. That's really what today is about. This is not creating any network. This is creating network that's built AI ground up. It's the network that's intelligent, network that can sense, network that can adapt real time, because that's what customers need. So today is the day. What are we doing in AI RAN? I think if you guys followed our Capital Market Day, it's almost a year ago, we announced this collaboration and partnership with NVIDIA and Nokia. And we are moving from 5G to AI RAN to 6G. We have done this in the past. If you remember, this was 4 years ago when T-Mobile and Sprint merged. We pioneered this 5G layer cake strategy. We said 5G is for all. 5G is not a technology that's only for stadiums. And the world followed. And we are going to do this in 6G era again. I'm so excited about this collaboration. We'll create this technology in US for the world to follow. So Ronnie, thank you for all the work on this. Justin, looking forward to connect it. Thank you.
Thank you, Ankur. Stay up here for...
Maybe I'll just ask us to all come up on stage. And firstly, thank you very much, Ankur. It's great to be working with you. Look forward to the new partnership.
Absolutely.
I think, as you've all heard today, we have an amazing future in front of us. You want to stand under NVIDIA?
Yeah.
I want to go stand under Nokia.
You're welcome to, by all means. All right. All right, maybe we'll shake hands. All right.
All right.
Thanks very much.
Thank you. Thank you, guys.